Hey guys, welcome to my channel Coding Shinobi. In this tutorial, we'll break down the LeetCode problem Roman to integer step by step and implement an optimal solution in Java. The problem statement is like you are given a Roman numeral as a string and you have to convert it into an integer. The input will always be a valid Roman numeral within the range of 1 to 399. The Roman integer supports the range from 1 to 3999. Only numbers up to 3999 we can convert using the Roman symbols. The mapping of the Roman numeral system is given as follows. Like I is mapped to 1, V is mapped to 5, X to 10, L to 50, C to 100, 5, D to 500, and M to 1000. Normally, values are added from left to right. But there is one exception. If a smaller value appears before a larger value, it is subtracted instead of added. Let's see with the example test cases. If you have given this string VII, what is the value of V, which is 5, value of I is 1. So the addition rule is simple. 5 plus 1 is equal to 7. Normally, the values are added from left to right. Let's take another example. S is equal to I, which is equal to a value of I is 1, which is 1 plus 1 plus 1 is equal to 3. Next example is LV triple I. The value of L is 50 plus value of V is 5 plus, as we have seen, value of I is 1 plus 1 is equal to 55 plus 3, 58. Now let's consider the subtraction wale cases. The value of I is 1 but the value of V is 5. Since 1 is less than 5, 1 is subtracted from 5. Value of IV is 4. Similarly, if you consider an or IX, the value of I is 1, the value of X is 10. The answer is 10 minus 1, which is equal to 9. Another example could be XL. The value of X is 10. The value of L is 50. So since 10 is less than 50, 50 minus 10, then XL becomes XL. The value of XL is 40. Now let's consider this given example. The value of M is 1000. The value of C is 100. And the value of M is 1000 again. Since 100 is less than M, we need to subtract the value of C, which is 100, but we will add the value of M, which is 1000. Again, if you consider XC, the value of X is 10, but value of C is 100. Since X is less than 100, we need to subtract the value of C, which is 10. Oh, sorry, the value of X, which is 10, plus the value of C, which is 100. Similarly, for IV, the value I is 1 and V is 5. 1 is less than 5, so we need to subtract 1, but we need to add the value of 5. The answer for this equation comes out to be 1994. Now, if you observe the pattern in the subtraction wala cases, you can see the subtraction cases are only occurred for the 4s and 9s itself. Like, if you observe the pattern, it occurs only for 4 and 9's value only. If a smaller number appears before a larger number, we subtract it from the total instead of adding. The approach is very simple for this problem statement. For the mappings, we need to create a hash map so that the lookup time becomes big of 1. And step 2 is we will traverse the string. And if the next value is greater than my current value, then only we will subtract the current value from the total. Let's start with the pseudocode and then we will do the dry run on that pseudocode. Okay. I have this total variable which I will return in the end, whose initial value is 0. Then I will maintain the previous value flag, whatever is previous value it is, so that I can check if whether to add the current value or subtract the current value from the total. Then I will iterate the string from the end of my string. You can iterate from left to right as well as from the right to left. No issues. And being the length of string I is greater than or equal to 0 and minus. So whatever is my current value, this map is the mapping of Roman numerals to its corresponding integer value. It could be a map of character, comma, int. We will see this working when we are coding it, but as of now, let's just consider this pseudocode. and assume that we have this map already created with us. Then what I'll do is, if my current value is less than previous value, then only I'll subtract it from the total. As we have seen, the exception in the while calculating the Roman numerals is like if smaller value appears before the larger value, then we have to subtract it. Else we will just add the current value into my total. Let's do a dry run on this example. Initially, my I starts at the value from the last character of the string, which is 6. My current value is value of v, which is equivalent to 5. Let's have this table handy so that we know what are the values of the Roman symbols. So the current value is 5, and my previous value is 0, and my total is 0 currently. So if current value is less than previous value, 5 is less than previous value, no. So we just add it to the total, which becomes 5. Now we subtract the value of I, my I becomes 5. The current value of I is 1. Also, we need to update the previous value as well. Previous value is equal to current value. I'll update my previous value to the current value, which was 5 itself. Now 1 is less than 5. So we need to subtract it from the total, which total was 5 minus 1 is equal to 4. Now I update my previous value to the current value, which becomes 1. I go to the next character, which is C. What is the value of C? 100. So my current value is 100. Is 100 less than my previous value? No, that's why we add it into the total. 4 plus 100 is equal to 104. I'll update my previous value, which is 100, and we move to the next character, which is x. What is the value of x? 10. And current value is 10. Is current value less than previous value? Yes, so we subtract it from the total value, which becomes 94. And for the next character, m, which is 1000. Is 1000 less than my previous value? No, so we add it to the total 94 plus 1000, which becomes 1094. And I'll update the current previous value. For the next character, C, which is 100. Current value is 100, and is 100 less than 1000? Yes. So we subtract it, which becomes 994, and update the previous value. Now for the last character, which is M, which is the value is 1000. Is 1000 less than 100? No. So I add it to my total, which comes out to be 1994. So this is how you convert given Roman string to its corresponding integer value. We just return the total from here, okay, guys, after calculating the value. Let's analyze the time and space complexity first, and then we can move on to the coding part. As you can see, we iterate through the string only once. So this gives us the time complexity of big O of n. And since we are using this hash map of 7 entries only, so it space complexity is kind of big O of 7, which is again big O of 1. Big O of 1 stands for constant time space complexity. So let's move on to the code part.
So I have already created this map of Roman symbols to its corresponding integer value. Now we need another variable which is total, which is initially 0, and we need another variable to see the previous value. We just have this variable n which will store the length of string, and then iterate the string from right to left. I need the current value which I can get from my map. Then I'll just check if my current value is less than previous value. If it is, then I'll subtract from the total, else I'll just add it into my total, and then in the end I'll update my previous value, whatever it was the current value. Then in the end I will just return the total. Let's run this. Let's run this code. Now submit it. The solution has been accepted. So I hope you guys have understood the problem statement and also the solution for this problem statement. If you really like this video, hit the likes button and make sure you subscribe for the more upcoming videos. I'm going to create the playlist of easy lead code problems first, and then we'll move on to medium, and then we'll move on to hard problems as well. So thank you so much guys for watching the video. I hope you are learning something. Happy coding, happy interviews. Bye bye. See you in the next video.